All right, and now we're up to the 2021 AMC 10A Problem 18, also the 12A Problem 18. And as we noted, it's the third problem out of 3 in a row that had the exact same numbers on both tests. I'm really sure that's the first time that's ever happened. So let f be a function defined on the set of positive rational numbers with the property that f of a times b is equal to f of a plus f of b for all positive rational numbers a and b. Okay, so I got a product of 2 rational numbers, and then I'm somehow able to split that like this. Suppose that f also has the property that f of p is equal to p for every prime number p. Okay, so for instance, f of 2 would be equal to 2. All right, Lex, before we read on, let's go ahead and use that here. It would mean that f of 2 times 1 equals f of 2 plus f of 1. And since this is still f of 2, these two things are equal, and we also learn that f of 1 is equal to 0. Okay, let's read on. For which of the following numbers x is f of x less than 0? Well, we could try to maybe graph it, right? But you'd probably be depending on reasoning that relied on the idea that it's a continuous function. And it doesn't really say that anywhere. We don't know that it's a polynomial or anything like that. It could be a discrete graph. It could be going up and down below the x-axis. We don't really know. So I don't think graphing is going to help that much. So the next thing would be, let's look at the answers, right? We've got 17 over 30, because you're going to have to evaluate them. For which of them? So we're probably going to have to test them out, right? So let's just try this 17 over 32. If I plug that in, one thing that catches my attention is 17, 11, 7, and 7 are all primes, and that's the product of 2 primes. So maybe we can do something with that. If I put the 17 over 32 in and made it f of 17 times 1 over 32, then this would equal f of 17 plus f of 1 over 32. Now we know what f of 17 is because it's prime. It's just going to equal 17. This one, though, we don't know about a ratio of like f of 1. Isn't this f of 1 over f? It doesn't say that. We can't make that assumption. So, what can we do? Maybe we could try to focus on a fraction that multiplied with an integer, like half times some integer, such that we got f of 2. Well, then that integer would have to be 4. Why 2? Because we know something about 2 already. So if I used 4 here, this would become equal to f of 1/2 plus f of 4, and that's what this becomes equal to according to the property, right? And so then we would say that's equal to f of 2, because 4 times 1/2 is 2, so this would actually be equal to 2. But what about f of 4? Well, we could say it's, right, f of 2 plus f of 2. So we can see that 2 times 2 makes this 4, and again, by the property, that is allowable for any rational numbers. They don't have to be unique. So this is 2 more 2's, right? And since you have a 2 here, this 2 would cancel that 2. It's going to end up, this is 2. Okay, I'll write it for you to see. So it cancels that 2, and then you're going to move this 2 over, and now we see that f of 1/2 is equal to -2. But now we've got another tool that we can use to try to get to these two denominators of 16 and 32, and maybe even the 6. So what we're going to have to do is do f of 1/2 times 1/2, because that will equal f of 1/2 plus f of 1/2. Now that's -4, so now we know that f of 1/4 is equal to -4. Then what about for, we need 1/16, right? So f of 1/16 is going to equal, keep in mind that that is 1/4 times 1/4, right? This could be a and b right now. Then this will equal f of 1/4 plus f of 1/4. That's going to be -8. Okay, great. Well, that's great because f of 1/16 we could use with this b value here, right? It's going to be f of, can you see that on the board? You can. All right, so f of 11 times 1/16, which we know is f of 11 plus f of 1/16. And since 11 is prime, as we noted from the beginning, this makes it pretty easy. It's 11 plus -8, or 11 minus 8, which is going to be 3, but definitely not negative. So we don't need to worry about b anymore. How about we do it one more time? If I want the 1 over 32, you can actually see that f of 1 over 32 would be f of 1 over 16 plus f of 1/2, because 1/2 times 1/16 is 1 over 32. We can kind of start doing it mentally now. We're getting used to it. We're getting acclimated to the problem. Again, it all started with just little explorations that we built upon. So you've got, this is going to be -8 as it says. We already know that's -2, a combined -10. I can see this will be 17, f of 17 plus f of 1 over 32. It's ultimately going to be 17 minus 10, which is 7. So that's a positive number, and that's not the answer. How about the 7 over 9? We're going to have to find 1/3 now. Let's use a similar tactic there. Sorry that we're all over the board, but there's a lot of calculations, and it's really hard to be organized in a proper way. So for 1/3, we need to find f of 1/3 times another number. Well, we could just do 3, because 1/3 times 3 is 1, and we actually already know we've got f of 1 plus f of, not f of 1, let's just write it down below, equals f of 1/3 plus f of 3. But we know what f of 3 is. It's prime, so it's 3. And so this has to equal f of 1, because 3 times 1/3 is 1, right? And that would mean that f of 1 being 0, we now know f of 1/3 is equal to -3. And since this is going to be, again, f of 7 times 1/9, then we need 1/9, which we can get from 2 1/3. So the sum of 2 1/3, f of 1/3 plus f of 1/3, is going to equal f of 1/9. By the way, if I was solving this and not explaining to you, I'm probably not writing all these calculations out. I've already jumped ahead. I saw that 1/3 was -3, and I've recognized that f of 1/9 is going to be -3 plus -3, which is -6, and f of 7 is 7, so this is actually equal to 7 minus 6, which is 1, and not negative. Okay, but I'm drawing out a little bit because it is an advanced level question, and maybe you got lost a little earlier, so I'm trying to keep hammering home how the technique works to make sure that those of you who haven't worked with something this complicated before start to feel more at ease as we go through. And if I went too fast, just go back and rewind and, see how it works out again from the beginning. So this is, again, as we said, is f of 1/3 plus f of 1/3. We can tell then that f of 1/9 is equal to -6. And as we said, this is f of 7 plus, right, because the expansion, 7 times 1/9, f of 7 plus f of 1/9 is 7 minus 6, which is 1. Okay, how about this one? You could think of it as f of 7 times 1/6. 1/6 is not quite as easy as the other ones. It's not that bad. You can think of that as f of 7 plus f of 1/2 times 1/3. And we know that that's just f of 1/2 plus f of 1/3. And f of 1/2, where do we write it? F of 1/2 is -2. F of 1/3 is -3. We know that this is just -5. So then we've got 7 minus 5, right, is going to be 2, also not negative. It's got to be E, but you're probably feeling uneasy. Like, what if we made a mistake and this isn't incorrect reasoning or something? Then I need to catch that. So don't just rely on, I've eliminated all the others, it must be E, unless you're down to like 10 seconds, and then, yeah, do that. But 25/11. I'm actually going to erase some of this space now here because we just don't have enough anymore. I don't need that really So here we go. It's going to be f of 25 times 1 over 11. So that's going to be f of 25 plus f of 1 over 11. So the 1 over 11 is going to equal negative 11. And you can get that if you just did f of 1/11 times 11, right? That is f of 1/11 plus f of 11, which is 11. And you know that this is 1, so f of 1 is 0. If I subtract the 11, you should have picked up by now that all of the prime denominators, 1 over those, the reciprocals of primes, if you will, is just the negative version. So we know that this is negative 11, and f of 25 is really just f of 5 plus f of 5. And since those are both primes, this is 5 plus 5 minus 11. It's E, a super challenging problem if you've never done weird function stuff before. To be honest, in my earlier years, or even when I was in school, this would have been too demoralizing probably for me to get. But, now that I've had more experience, it's been a lot easier, which is why you should be trying to get more experience by solving similar type problems. I think Volume 2 might have this. Volume 1, I'm sure, has it as well. Maybe in the algebra book. I'm not quite sure where you would find stuff like this. If you know, you can leave it in the comments. Maybe you can even link to a PDF or something that has problems like this on it for other commenters to read and use. That would be great. We're done with this problem. On to the next one.